So you think you're covered, right? You've locked down your AWS environment, you've battened down the hatches on Azure. But what if the real danger isn't inside your clouds, but in those invisible bridges connecting them? Today, we're going to pull back the curtain on the kind of multi-cloud attacks that most security teams just don't see coming.
Okay, let's kick things off with a number that really paints the picture: 80%. Yeah, that's how many companies are now using more than one public cloud. This isn't some fringe strategy anymore, it's just how business is done.
And right there, that's the heart of the issue. You see, while business has gone full-on multi-cloud, our security playbooks, a lot of them are still stuck in the past, kind of treating each cloud like it's its own little island.
And look, this isn't just some small gap in your coverage. It's a massive, dangerous blind spot. And it exists for one simple reason. Attackers see your setup completely differently than you do.
I love this quote because it just nails the whole problem. Defenders, we tend to think in lists. It's like a checklist, right? Secure AWS? Check. Secure Azure? Check. But attackers, they see a web, they see a graph, and all they need is one weak connection to build a superhighway right to your crown jewels.
And that difference in perspective, it's everything. On the one hand, you've got the standard way of thinking. You test each cloud separately in a neat little box. But the attacker's mindset, they couldn't care less about those boxes. They're testing the interactions, the messy connections between the clouds. And that's where the real gold and the real risk is.
All right, enough with the theory. Let's make this super concrete. We're going to break down a real-world attack scenario we call backdoor data exfiltration. This is going to show you exactly how an attacker can literally hop from an AWS environment straight into Azure. So here's how this attack chain plays out, step by step. It all kicks off with a pretty standard compromise in AWS. Could be anything, maybe a vulnerable server. But here's the key. The attacker doesn't stop there. They start digging around, and what do you know? They find some credentials for an Azure subscription, maybe just sitting in a config file someone forgot about. From that point, they use that compromised AWS machine as their launchpad, pivot directly into Azure storage, and just walk out the front door with your data. To them, it's all one big connected playground. Okay, so the worst has happened. The attack went down, the data's gone. Now you're the one on the incident response team trying to figure out what on earth just happened. Where do you even begin? Well, let's follow the digital breadcrumbs, starting right inside the Azure logs. The whole investigation can actually start with one simple query. You can basically ask your Azure storage logs a very direct question. Hey, has anything connected to my storage that happens to mention AWS? That user agent header is like a digital fingerprint, and we're hunting for a very specific one. And just like that, ping, you get a hit. The query spits back a log entry that shows a connection from a specific IP address. You do a quick search on that IP, and yep, it's registered to Amazon Web Services. That's it. That's your first huge red flag that something is seriously wrong here. A call to your Azure storage came from inside an Amazon data center.
But wait, it gets even better. We can dig deeper. Let's really pick apart that user agent string from the logs. Okay, we see they use the Azure command line, the Python SDK for storage, but then look at that last piece, Linux AWS. That's not just any old Linux machine. That's a kernel specifically built for and running on an AWS EC2 instance. This is the smoking gun. It's the ironclad proof of a cross-cloud breach.
So we found them. Great. But let's be real for a second. We found them after the damage was done. The data's already out in the wild. Finding the breadcrumbs after the fact is not a winning strategy. It's time to stop chasing yesterday's attacks and start getting ahead of tomorrow's.
And that really brings us to the big question, doesn't it? Is detection really enough? In a world where a single breach can cost you millions, maybe even your reputation, the answer has to be a resounding no. We've got to get proactive.
So how do we do that? How do we get ahead? Well, it's with a strategy called adversary emulation. The idea is pretty simple, actually. Instead of waiting around to get hit, you practice. You safely mimic the exact techniques an attacker would use. When you do this, you're not just testing if your alarms go off. You're also teaching your team what real malicious traffic looks like, which helps slash all that alert fatigue from false positives. Of course, thinking like an attacker is one thing. But actually having the tools to safely test your environment like one, that's a whole other ballgame. And this is where some really cool platforms come into play. A great example is Mitigant, which is built specifically to take that confusing, complex attacker's eye view and turn it into clear, actionable insights for defenders.
So what Mitigant's platform actually does is give you a safe sandbox to run these kinds of attack emulations. Remember that backdoor data exfiltration scenario we just walked through? You can run that exact attack and tons of others to see for yourself if your defenses actually work, long before a real attacker decides to try.
Okay, this has been a lot of information. Let's boil it down to what you can actually do. How can you start taking charge of your multi-cloud security like today?
Here are your next steps. Super simple. First, the big takeaway. You have to start securing the interactions between your clouds, not just the clouds themselves. Second, your strategy. Get proactive. Adopt adversary emulation to find those blind spots before the bad guys do. And third, the action. Go try this out. You can actually sign up for a free trial of Mitigant's platform and start running these tests in your own environment.
So, I'm going to leave you with one final question to take back to your team. A really important one. Are your clouds just secure in isolation, or are they actually secure together? Because I can promise you, right now, attackers are betting they aren't.